So we have a new member in the YOLO family, YOLOv10. It was just released yesterday. We're going to create a video on how we can train a custom YOLO10 model in this video. Every single step from scratch. We're going to see how we can generate a dataset, connect to a webcam, store individual images, how we can upload them to Roboflow for labeling, export into a Google Colab notebook, and see how we can fine-tune a YOLOv10 model. Then we're going to export and run it live on a webcam to see how we can set up the whole computer vision pipeline. So let's just jump straight into the YOLOv10 GitHub repository. We're just going to scroll through it quickly. So it's just released yesterday. Here we can see the benchmarks, where it compared to all the other versions in the YOLO family. So we have YOLOv6, YOLOv7, 8, 9, now also YOLOv10, but it also compares it to some of the other YOLO models and also the real-time detection transformer. And just by looking at the results, we can see that this model is significantly better on the Coco dataset. So just to make it clear, this is still on benchmark, so the Coco dataset benchmark. Could be that some of the other models are still better for your specific applications and projects, so definitely test out various models on your specific dataset. So right now, we're just going to take a look at the results. We can see the mean error positions. We have better performance on pretty much all the models, but the huge advantage from the YOLOv10 model compared to all the other YOLO models is the inference speed and the latency that we can see down here on the x-axis. So we can see that it only takes around 2 milliseconds to process a single image with the nano model. We have the nano, small, medium, large, and extra large model, the exact same variations as we have with YOLOv8. So this is actually built on top of the Ultralytics framework. We can use all the models from Ultralytics directly, training, validation, inference, export the model, and so on. So that is built around that framework. If you just go through it, we can see here we can download all the weight files. We can see the number of parameters, floating point operations, and also how to set up the environment. But let's just jump straight into it and see how we can do it on our own. So when we're starting out with the computer vision pipeline, we need to generate a dataset. I'm going to show you the whole pipeline here. There's a ton of videos out there just showing you how you can go inside a Google Colab notebook and fine tune a model, which is relatively easy. But here we can see how we can generate images from a live webcam, which is most often the case. Or you could have like an image folder. We can upload it into Roboflow and annotate them. So right now I just have this generate images Python script. So what it does, we're importing the different modules, so CV2 and also our operating system. We connect to our webcam. So if you have a video file, we can also specify the MP4 file, video file, and so on in here. But right now we're just going to connect to a webcam. Could also be an RTPS stream. First of all, we're going to check if the webcam is open. If not, we're just going to print that it's unable to read the camera feed. We create our output directory. This is where we're going to store all the images to our dataset. We then have our while loop just loading in frames from our camera or video stream. We show it here with our imshow function. We check which of the keys that is hit on our keyboard. If we hit escape, we will just terminate our program, close down our webcam, and then we can use our output directory as our dataset and upload it into our computer vision pipeline. If we hit S on our keyboard, we're basically just going to create an image name and then write out that image to our output directory so we can generate our dataset. So that's pretty much it. Let me just open up a new terminal. There we go, and we can just run this Python script. So generate images.py. Now I'm going to run it. It's going to open my webcam right here in front of me, and we can capture some images. So here we can see that it has pretty much just opened up this webcam, and right now we can hit escape. It will terminate the program, or we can hit S on our keyboard. So right now I'm just going to hit S. We can take up different types of objects. So right now we can have multiple objects. So this is my Apple Wallet. We can just hit S. We can see in the terminal that it actually saved these images. So say that we want to create a data set where we want to detect this wallet. Could also add my phone here as well. There we go. And then we'll just have to generate X number of images. If we want to fine tune the YOLOv8, YOLOv9, YOLOv10 models as we're doing now, we probably need 100, 200 images. We can always do data augmentation later on. But this is just to show you guys how we can have a data set. I'm going to show you some we already have on Roboflow that we can use directly to train our YOLOv10 model. So right now I'll just hit escape on the keyboard. Let's go over and see if we actually have our output directory. So right now we have our output images. If I scroll a bit further up, here we have our output images, and we have all the individual images that we have saved in here for my Apple Wallet, but also my phone down here at the end. Then we can take this data set, upload directly to Roboflow, annotate it. We can draw the bounding boxes, the auto annotation tools. We already have videos covering every single step in there and also in more details. Now I'm just going to show you that on a high level. So if we go inside Roboflow, we can create a new project. Right now, let me just call it wallet. And here I'll just have a class called wallet as well. We can choose between object detection, classification, instant segmentation, and key point detection. I'm just going to create this data set. Right now we have the data set. We can go inside our code files again. I'm going to reveal it in Finder. There we go. Then we have all our images. We can just upload a batch of it. There we go. I'm just going to drag them in. It's going to upload them and we can go in and annotate them later on. So right now it has uploaded it. We're going to save and continue, and we can always export it later on as well. So now when our images are uploaded, we can start the annotation. Right now we only have like 20 images or like 16 images. So it might not be enough to train a model, but we can just test it out. And this is like the whole pipeline that you need to set up. I just need to annotate each individual one of them. So here we have phone. I'm just going to annotate all of them, and then we can start training a model and also use data augmentation. So now we have annotated our images. I'm then going to add it to the dataset, and we can specify how many images we want to use for train and validation. Right now, I'm just going to have one for each, or probably there's just a couple for our validation, just to make sure that we have enough. So I'm just going to add it to the dataset. Again, this is not enough data at all. We probably need like 100 or 200 images, but it is exact the same steps that you need to do if you're creating your own projects. So right now we have our dataset. We can go in and create a new version. If we go inside generate, we can specify the size of it, auto-orientate, or if we need to add other pre-processing steps, probably just go with the default settings. They're more than good enough. Also, when we're going to train the model, just always go with the default settings unless you want to train something specifically or testing out multiple models. So let's now go in and add some augmentation steps if you don't have enough data. And this is the reason why we only need like 50, 100, 200 images in our data set, because then we can just use data augmentation. So right now I'm just going to add some flip, both vertical and horizontally. We can add some zooming effect as well with the cropping, and then we can just add how many images we want to have in our data set. So now we're pretty much ready. We have all the steps in here. We can specify how many images we want to generate. So right now let's just go with 7x. So we have 81 images in our data set. Let's see if that's enough, even though we probably need 100 more images to have a really good model, but we'll still be able to train it. We'll still be able to fine tune it and get some results out that we can take a look at, and also run live inference where I'm moving my phone and the wallet around as well. So now we can go and export our data set. We can go in and specify the data set format as well. So right now we can just use any of these ones from Analytics. So we just need the exact same format. So we can take YOLOv10, for example, you can download the zip file to your computer, or we can get this downloadable code. If we hit continue here, we just get a code snippet. We can copy it, paste it directly into our Google Colab notebook. So we have our code snippet here. We're going to copy it so we can paste it into our Google Colab notebook in just a second. So now jump straight into the Google Colab notebook that we're going to use for now. First of all, we need to specify the runtime, so we can change the runtime. You can use the free GPU resources in here so we can speed up the training process. So right now I'm just going to choose this T4 GPU. Make sure that you do that, and then we can connect to the runtime and we'll get a T4 GPU assigned to our environment. Once it has connected here, let's go in and run this NVIDIA ASMI command, which basically just shows us the information about our GPU. And here we can see that we have our Tesla T4 and around 15 gigabytes of GPU RAM. So that's pretty good. Right now, we're just going to import our operating system so we can create this home directory and set that, which is our /content in a Google Colab notebook. So that is the file system that we have over here to the left. Now we need to just go in, pip install the new YOLOv10 model and also supervision, so we can use that to show the results later on and basically just do inference. So right now we're just going to process each individual one of these. We're going to pip install YOLOv10, and it will also be integrated into Analytics, so you can use it directly with Analytics. We can call all the commands and so on because it is built on top of that framework. After we've done that, we need to go in and create a directory with our weight files, and then we're going to pull and download the weight files from the GitHub repository. So this is just the URL for the download link, and then we just call this command vget and copy all the weight files into our new directory. So that's pretty much everything that we need. If we just go inside it again, this is actually like just a link. If you right click on this one here, you can copy the link, and this is the download link that I'm showing. You can also just press on these and it will download it to your computer. So that's pretty much it. We can just run this block of code, and let's go down and take a look at how we can run inference. So I'm just going to take an arbitrary image, upload it into this Google Colab notebook environment so we can run inference and just see some initial results with a pre-trained model before we fine-tune it on our specific dataset that we just created from scratch. So just upload this image to the Google Colab notebook, just a screenshot from a video, and let's try to go in and do inference on it. So I go over to the left, copy the path, and then I just need to specify it in here for the file name so we can show it to start with. So we're just going to use IPython to display this image, and this is pretty much the image that we're going to throw through the model to be able to detect these bags and also suitcases. So to be able to run inference, this is the exact same thing that we're going to run later on live webcam, but in Python code. So we call the YOLO command. We want to do object detection. We want to do prediction. So this is the mode that we need to specify. We can set up the confidence score. We want to save the results and also specify the path to our model weights. And we can choose any of them. So small, medium, nano. And this is the exact same way that you will do with YOLOv8 and also YOLOv9. So right now, let's just go with the small model. We need to specify our source. So right now that is not a video, but our image over here to the left. So just copy it. Replace the source here, and we specified our image, and we should be good to go. So we cd into our home directory, call the YOLO command, and do inference on just a single image. So it might just take some time just to load up the model, but the inference is very fast with the new YOLOv10 model. So here we can see that I actually got an error. We haven't specified the correct path, so we have content twice. So I just need to make some modifications with that. I just copied the whole path here. We don't really need to have content in front of this one because we have our home directory. So it should be good to go now. I just rerun it. We have content and we're doing prediction now. There we go. We load the model and we do our inference. It takes around 100 milliseconds because we're only processing a single image right now. So yeah, that's pretty cool here. We can also do it in raw Python code. So from Autolytics, we import YOLOv10, we create an instance of our model, and then we just call our source directly on the model instance, and we get the results out here, which we can extract. So that's pretty much it. Let's just go in and take our image again, copy the path, and this is the exact same way that you will do it in Python. There we go. We can run this block of code with Python. We get our results. From the results variable here, we can extract the bounding boxes, the XY values, confidence scores, and classes. So I'm just going to do that. We're going to print it out. So here we have the XYs for all the different classes that we're detecting, which is most likely suitcases. CUDA device here, we're using GPU. We have our tensor with our confidence scores and also classes. So here we can see that these are the class labels for suitcases in the Coco dataset. So these are the pre-trained models that we're using right now, but we're going to fine tune it on our own dataset in just a second. So if you want to use supervision to visualize the results and the predictions directly from our results variable here, we saw how we can extract it. Now we need to know how we can visualize the results. So I'm just going to copy paste this image again. We throw it in here. There we go, and we should be good to go. We load in our model weights, and now we're using supervision to draw our detections. We create these detections from our results. Have a bounding box annotator, label annotator, and then we just plot that on top of our image. And here we can then see we have our bounding boxes plotted on top of the suitcases detected in this image. So we have some false predictions here and also here, but could probably be filtered out with a confidence score. So right now, let's go down and take a look at how we can set up and download a dataset from the Roboflow. So right now, I'm just going to go in, copy our code snippet. We paste it in here. Then we run this block of code. It will download the dataset automatically. Then we can just call the path to our dataset and train our YOLOv10 model. So if we go over to the left now, we now have our YOLOv10. So this is the dataset that we annotated from Roboflow. We have our test images, training, and also validation. And then within each folder, we have our images and also labels. So another cool thing here is that we have our data YAML file. So this is a structure that Autolytics and all the YOLO models are using. So we just need to specify the path, and I just like to do that manually because sometimes it messes it up. So image path here, I just copy the path and change it out here for test, train, and also validation. So here we have valid and we have train. There we go. We hit Control S just to save it. And then we just specify here we have Roboflow, the number of classes we have 2, which is the phone and the wallet. We should be good to go now. Let's close our directory and we can then do custom training. To start with here, we're just going to go with 25 epochs. The batch size probably be a bit too large here, just with the 3 GPU. So let's go with 8 for now. We want to plot it and also specify the model. Let's go with the nano model for now because we don't have too much data in our dataset, and also specify the data file or the path to our data YAML file. So that's pretty much everything that we need to do. And again, this is the command from Autolytics that we're just running directly. And here you can just swap this model out with YOLOv8 or YOLOv9 if you want to train those models. Just because we have better benchmarks on the Coco dataset for the YOLOv10 model doesn't mean that YOLOv8 and also YOLOv9 would be able to outperform on your specific dataset and task. We get a summary of the model. First of all, it will download it. It will set up the whole data set, both with our training set and our validation set. So we have 77 images in our train and 3 in our validation set. So when we only have 3 images in our validation set, our training results epoch per epoch might look a bit off, but let's take a look at it once we evaluate the model and do inference later on. So our model is now done training for 25 epochs. Let's just take a look at the results. Just after a single epoch here, we already get pretty good results with the mean error precision of 0.80, but it should be able to increase over time, and also the losses come down. So here we can see that the losses 1.4, 3.4, 1.6 here, they are decreasing over time as well. And also the mean error precisions, it is fluctuating a bit in the start because it's modifying and optimizing the weights a bit more in there. And then we kind of just start to converge up here. The mean error precision of 0.50 is pretty much spot on. They should be close to 1. And we can also see the precision recall is also fairly good once we come down here at the later epochs. So let's just go all the way down to the bottom and let's take a look at the final results. So yeah, we have pretty good results. Pretty close to 1 in both precision and recall. Again, we only have 3 images for our validation. So of course, ideally we want to have more images, and also here we have images, instances, and our precision recall and mean error precision. So this is the validation that is running on the validation dataset with our best trained model. So if we go over to the left here, we then have our runs directory. If we go inside runs, we have detect, and then inside detect, we have train, we have our weights, and right now we can just download the weights and use them in our Python application and projects. And I'm going to show you that in just a second, how we can upload it, how we can open up the webcam stream, set it up, draw our visualizations, and use this model in your own applications and projects on a live webcam. So let's just download the model here, and then we can use it later on. But we also have all the other training graphs here. We have our F1 curve, precision recall curve. Let's take a look at that. It should ideally be close to 1, and we can see here that it is pretty much just spot on. For most datasets, you can probably expect it to curve out here a bit towards the top right corner. Another good way is to look at the confusion matrix. Ideally, we want to have all the values in the diagonal. It makes a bit more sense when we have more classes, but again, we want all the values to be in diagonal. Right now, we only have 3 images in our validation set, but this is pretty good to take a look at. We also have our training batches here, both a training and also a validation batch. Let's just take a look at our training batch. Our validation batch, it hasn't been training on those images before. Here we can see all the different predictions, or the bounding boxes around these images that we're training our models on. If you're taking a look at our validation batch here, it's just going to throw in the 3 images and do predictions on top of that. So we can see that the model here is actually able to detect the phone and also the wallet in pretty much these cases. Again, you only have 3 examples, so let's try to open up a live webcam and see how it performs. So right now, I'm just going to go inside our code editor again. Let's go in and grab our code from generate images. I'm going to show you how we can set up this whole pipeline. We have our best.pt, so this is the model that I just downloaded. Let's make this a bit smaller and this a bit larger. So right now we don't need our output directory anymore. So let's go in and delete that part. Image counter, we can keep that for now. And we don't really want to hit S on our keyboard either. We just want to hit escape for closing our application and show our results. So in between here, we need to run inference on our images, but we need to set up a model to start with. And if we just go inside our Jupyter notebook or our Google Colab notebook again, we can go in and grab the code that I showed you guys earlier on. So let me just scroll up. There we go. We kind of have the whole code base here. We need to import supervision and also YOLOv10 from Autolytics. There we go. And now we can set up our model and also our image. We don't need to do that right now. We can just take our model, create an instance of it outside of our while loop. And now we just need to specify best.pt. There we go. And this is how easy it is to set up with Autolytics and the whole framework around that. So right now, let's just grab this one here. The bounding box annotator, the label annotator can also be set up outside our while loop. So let's do that. And this would actually go inside our while loop. So first of all, we need to do our predictions. After we have done our predictions, it's going to basically just throw it in here. And to get our results, we do this. And instead of image, we need to swap it out with our frame. So we grab our frame, throw it in here, we extract the results, and then we're going to use supervisions to create this detections instance and for image down here as well. Now we have our annotated image with both our labels annotated on top of it and also our bounding boxes. And then we can go in and just visualize our annotated frame. So this is pretty much the whole pipeline. Now we can just run it on a live webcam, see how it performs, and move my phone and wallet up in front of the camera. And this is how easy it is to use in your custom applications and projects. If you want to extract the individual results, again, you can go up and use these ones. So you can just access the bounding boxes, the X, Y values, confidence scores, and also classes. And you're pretty much good to go. You can use it for whatever application that you can come up with. And you can also use a custom dataset, an arbitrary dataset. I just took this dataset here while doing this video. You can use an arbitrary dataset. There's also a ton of datasets on the Roboflow platform, or use your own. So this is a pretty cool way to learn how to set up this whole computer vision pipeline. We're good to go. Let's now go down and run our Python application. So webcam inference.py, let's run it and take a look at the results. So now we can see that our model is up and running. I'm just running this on a CPU right now. On my MacBook, we're running around 70 milliseconds inference time. So that's pretty fast as well. That's around 12, 13 frames per second. So that is actually like pretty cool just by running on a CPU, and you'll get significantly speed ups by using a GPU as well, especially with this new YOLOv10 model, where I feel like this is the advantage that you get is the inference speed or the latency, how long it takes to process a single image. So let's just take the phone now. Let's move it up and see if we can actually like get some predictions. So right now we need to have it like fairly close to the camera. I think we got one detection. Again, this is not an ideal model. We definitely need to have it for longer, train it for longer. Could also be because some of the reflections, but we actually get it in some specific situations or positions. So here we can see that it detects the phone. So this is pretty cool. We might get better results with the wallet here. Let's just try to move it up. I'm just going to rotate it around, and now we have the wallet that we're detecting in the frame. Of course, we miss a lot of detections here and there. We can probably also like lower the confidence score and so on. But now we have this custom trained computer vision model up and running. We can move it around in the frame and we still get these detections. Right now, we only do detections on each individual frame. You can also apply object tracking on top of it. I have courses around all the theory behind object trackers, how you can apply it on top of different object detection models, deep sort, sort, and all of those stuff. Go over the theory. It's all based on the Kalman filter, how you do a prediction state and also an update state. And then it's just like an iterative update prediction states. And this is pretty awesome because then we can assign an ID to each individual track or object that we want to track around in the frame. You can use it for object counting, tracking like how long specific objects are in the frame. But this is pretty cool. This is how we can set up a whole training pipeline. And again, just remember, I only captured around 16 images with both two classes. So my phone and also this Apple Wallet. So this is pretty awesome. Probably need to have it in this orientation because this is what we had in our data set. Let's try to see if we can get both predictions at the same time. Might not be the case. We didn't really have that situation in our data set. There we go. Now we have our predictions, and this is how easy it is to set up the whole pipeline. You can take all the code. It will be available on my GitHub, and you can have this up and running in 30 minutes. So thank you guys for watching the video here. I hope you have learned a ton. Definitely go in and test this out here. This is the new member in the YOLO family, YOLOv10. I've tested out a bunch here on a bunch of different video streams and so on. I'm not sure if we get better accuracies and results on custom datasets, but it is definitely a faster model compared to the YOLOv8 and also YOLOv9 model. But it all depends on the task and also the dataset that you have on your side. So go in, test it out. You can solve from this video here every single step in the whole pipeline. It is easy to do. You just need to follow the video. You're good to go. Use it in your own applications and projects. I hope to see you guys in one of the upcoming videos. Until then, happy training. So we also have an AI career program if you want to learn how to land AI jobs and get AI freelance work. I teach you everything in there. We have programs, all my technical courses, weekly live calls, personal help, and I'd love to have you guys in there, help you out in any possible way. You can check out the program down in the description and the community, and then I'll just see you guys in there.